Hello and welcome to this video. In this video, we are going to see the optical proximity sensors, types of optical proximity sensors and its applications, and also about ultrasonic sensors and its applications in industrial automation. Previously, we have seen these mechanical proximity sensors. They are contact type. So this optical proximity sensors are non-contact type of sensors. So this optical proximity sensors, they consist of a light source. Normally an LED is used as a light source, and light detector, a phototransistor will be available. So it will have a transmitter and a receiver, we can say. So the LED emits the infrared light, and the phototransistor, it detects the infrared rays. The modulation of signal to minimize ambient light conditions. So in optical proximity sensors, the light, that is light which is generated by using this source or the transmitter, it is normally modulated one. So because why is the external environment also, it may have the light sources can be there. So sometimes it may cause false triggering. So in order to avoid that, we use the modulation. So it is modulated in such a way that no interference will not affect it. Okay, so that is the reason for modulation. So here also, just like your mechanical proximity switches, it comes in a wide range of operating voltages. So here it comes with 12 volt to 30 volt DC and 24 to 240 volt AC. So the output will be TTL, or it can be a solid state relay. So as similar to the previous one. So the modes of operation, there are three different types of optical proximity switches are there. One is through beam, next is retro-reflective and diffuse reflective. So these are the three different types of optical proximity switches. So the through beam is nothing but, in the top you can see the transmitter and the receiver will be separate. Okay, the sensing, the object will be in the middle of it. So two sides, one side transmitter and the other side the receiver will be there. So the setup is made such a way that the light will be, it is focused on the receiver. Okay, here the distance we can go up to 20 meters using through beam. So this only thing is the alignment is critical here. So the alignment should be very perfect, and over time it should not change. So that will affect the sensitivity. So that is the only disadvantage that is there in the through beam. But the advantage is it can sense, the sensing range is high, up to 20 meters. Then retro-reflective type. So in this type, the range can be from 1 to 3 meters we can go, and these type of sensors are very popular and they are cheap comparing to the previous one, through beam. Here the thing is, here also the object, here there will be a reflecting surface will be there, reflecting object will be there, and here the sensor will have the transmitter and receiver at the same side. The same module will have both the transmitter and receiver, and the light will be reflected through the reflector and it reaches the receiver. If there is no object, then through the reflector will receive, the receiver will receive the light and it will activate. If some object comes in between the reflector and the sensor module, then the light will be interrupted and it will indicate that some object is between the reflective surface and the sensor. So next is diffuse reflection. So here the sensing range is very less, that is 12 to 300 millimeters, 3 up to 3 centimeter only it will be able to sense. So here this also it is cheap and easy to use. Here in this type it uses the reflection which is coming from the object. So the reflection, there is no reflector or there is no source in the opposite side, but the source and the sensor or both or the receiver or both in the same module, or say it faces the same side, but through the object it is getting the reflection. That's why the sensing range is very less in this type. So these are the three modes of operation, or the three different types of optical proximity sensors. So now let's see the pros and cons of optical proximity sensors. So as I told you before, it is a non-contact type of sensor. So there is no need for any touch. Okay, without in a distance it can sense the presence or absence of the object. There is no moving parts. So there some switches, the contacts are there. Here that doesn't have it. So also the size is very small. So these are very much advantages when we go for automation. And also the switching is fast. Fast switching can be achieved using this, and there is no switch bounce. Normally in mechanical switches there will be a bouncing. When the state changes, there will be a small bouncing because of the spring action. So the bounces, we have to take some precautionary measures to arrest those bounces either in the software or in the hardware. So here there is no bounce. Switch will not bounce. So we will get a discrete output. So here they are insensitive to vibration and shock. So the vibration or shock will not affect this type of sensors. So in this sensor many configurations are available. Different configuration, different range sensors are available. These are the advantages of using optical proximity sensors. Now let's see the disadvantages or cons of this type of sensor. So here the alignment always required. So the alignment is very necessary. So if the alignment changes, then it will give a fault or false output. Next is it can be blinded by ambient light conditions. So if some in an ambient light, or if any external light sources is present, then it may affect the performance or working of this sensors. That is, for example, some welding process is going on, then that then the arcs will be generated. So sometimes because of that the sensitivity may get affected. So these sensors requires clean, dust free and water free environment for their working. So these are the pros and cons of optical proximity sensor. So next we'll see the application of optical proximity sensors. So they are used in counting applications like box counting or bottle counting, the bottles in case if it is a bottle filling process, it can count the number of bottles or number of boxes. Then next is it can sense the fluid level control. It is used in fluid level control. Then breakage and jam detection. For that purpose also this can be used. Also it is used for obstacle detection and many other similar applications. Next is ultrasonic proximity sensor. So this is also a non-contact type of sensor. So this uses sound pulses, ultrasonic range sound pulses are used for measuring the obstacle or the distance, etc. So this measures amplitude and time of flight. So through that, by sensing the amplitude and the echo time of the sound pulse, it is measuring the obstacle or the distance. So this it provides more information other than on or off. It gives more additional information like the distance in millimeter or in meters or in centimeters or inches. We can get the information. The frequency of operation is 400 kilohertz to 2 megahertz. So here you can see the operation of the working of the ultrasonic sensors. So it comes in two different forms. So in the top one you can see a transmitter and a receiver. Two separate transducers are there. One is used for transmitting the sound pulse, and another is for receiving or detecting the sound pulse. So here the transmitter transmits the ultrasonic pulse. So if any object is present in the detectable range, so because of the object, it gets reflected. A part of the ultrasonic the sound pulse it will get reflected, and that reflection is sensed by the receiver. And by calculating the time the traveling time of the pulse, we can find out the distance of the obstacle or the presence of any obstacle. So in that way it is being measured. In some cases, the one transducer or one ultrasonic sensor transducer will serve the two purpose. So it can be used as a transmitter as well as a receiver. So it will have only one transmitter. Okay, so here it will send a pulse, sound pulse, and then it also senses the response, and then it calculates the time of the distance based on the time taken for the echo. So this ultrasonic sensors, they provide range data directly, as I told you, centimeter or meters in that information we can get from that. Then level monitoring of solid and liquid. So they are used in sensing the level of liquid or solid. Okay. Next is also it can be used in collision detection or obstacle avoiding application. It can be used. So before the targets or the object comes and hit some part of the machinery, it can sense and it can inform. Okay, so that some other necessary action will be taken to avoid. Next, it can work in heavy dust and water environment. So it is also a very robust type of sensor. So here one issue is if some ambient noise is more, external noise is available, sometimes it may affect the performance of the sensor. So now let's see a few example applications of this ultrasonic sensor. The first is waste bin level monitoring. Now we talk about smart city, then smart waste management. So for that purposes, we need smart waste bins. So in order to monitor the waste collected from a remote control station, this type of sensors are used with some sort of transmitters. Okay, so some IoT like applications. So this, for such applications, this sensors are used. Okay, it senses the level of garbage collected in the waste bin, and it sends a signal, or it sends the information to the station. Next is fuel level monitoring in automobiles or in any industrial fuel storage tanks. So using this ultrasonic sensors, so the level of fuel or any liquid or any edible oil or anything can be monitored very easily. So also in automobiles, also nowadays the amount of fuel is sensed by using ultrasonic sensors. Previously, some capacitive type of sensors were used for sensing the fuel level in the tank. In that case, that fuel tank has to be modified. Okay, some modification had to be done in that. Some holes has to be drilled, and the electrode has to be inserted inside the vehicle fuel tanks. Now, using this ultrasonic sensors, without making any modification in the fuel tank, just by sticking the ultrasonic sensors in the bottom of the fuel tank, you can monitor the fuel level in the tank, also fuel consumption. So these things in vehicle tracking application, this sensors can be used. Then in paper rolling mills, the thickness of the paper rolls or the papers can be monitored, so sensed by using this ultrasonic sensors. In this video, we have seen about the optical proximity sensors and ultrasonic sensors and its applications in industrial automation. The next video will be looking into the other different types of sensors. Thank you.